Okay, Javier, this is one of the new inventions. It's basically a playground for the SynFramework. Because one of the requests that gets the most is how do we implement this? And how does it work? And you can see it in a video or things like that, but it's not the same than to use it. And I was trying to find a way to make this work without any server infrastructure. So the idea behind this prototype is that it uses everything on memory. And since it's targeting Net 6, you can actually run SQLite in memory and do all the operations as if you were with a server or something. So it's really neat. It shows how the framework works, and people can give it a try before start writing code to implement this. So this is the basic idea. We have a server node, and in the server, you have the deltas that are stored in the server. At this moment,
before we move forward, and I know that a lot of people that follow us and work with us in our Suffers community, stand up, and even in our Arizona user group, they know this. But I would like for someone who watched this demonstration for the first time to understand all the complexity that a synchronization framework or a synchronization operation take place. So let's give them a quick 2 minutes background about deltas, about source of truth, about the synchronization through an ORM, meaning that we can synchronize between different type of database. That way, when we jump to the nodes, the deltas, and everything there, they completely get the whole picture.
Yeah, so the idea here, and we can see this in the GitHub repository, is that this synchronization framework implements a theory that is called delta encoding, which is the idea that if you record the difference between the object A and the object B, and you put them together, you will have a complete data set. So the idea behind the framework is record those small differences that happens between database transactions. That is what ORMs do in the end. And if you put them together again, you will have the complete data set, which will be the source of truth or the complete database that you were trying to synchronize. So each of those little differences are called deltas. So every time that you do a transaction, you create a delta. So, and then you need a way to put those deltas in a centralized place and be able to get them from another client or node. And if you put all the deltas together, both nodes will look exactly the same. So in the end, the theory is kind of really simple. It's an equation, which is this equation here, which means that the sum of deltas will be equal to the source of truth. And source of truth is considered the entity, database, or dataset that you have that contains all the deltas. So that is basically the theory. You have other problems like, how do I store them? How do I send them to a server? How do I share them between nodes so each node can get the delta that is missing? So those are another set of technical problems, but the theory is kind of really, really simple. It's just record the little changes and then put them together. You will have the original data set. So that's what the server does. The server basically is a repository of those changes or deltas. And then every time that we create a client, the client will generate a set of deltas that it can share with other clients. So to exemplify that principle, we add a node here. And at the moment, it will take a little, like a few seconds, because it initializes the database in memory and so on and so forth. So now we have a client here. This is a really simple database, which is a set of contacts with phone numbers. And all these 3 contacts with each of them has 3 phone numbers. So all those records were created in a single database transaction. That's why here in the side, you see only one delta. So if we want to take a look at this, you will see that, see, this is the transaction. This is what happened, like a person was inserted. And you will see the SQL like query for each of the database engines that are supported, that are SQLite, Postgres, MySQL, and SQL Server. And then you will see the data, the data values that it was used for these queries to execute. So you will see like all the queries there. And I try to create a UI that allow you to understand the functioning of the deltas and what are we recording on the deltas. You can also download them if you want to take a look to the file. And these are valid SQL queries. If you run them, they will execute on your database engine. You just need to pick the right engine to run them.
Okay, and shows that those SQL statements, they differ from databases engines.
Let me download this again. And see, for example, we are storing in SQLite. That's why it's the first on the list. But then you can see, like, for example, for SQLite, C persons is between double quote. For Postgres, it's kind of the same. But for MySQL, it's single quotes. And for Microsoft SQL Server, is in square brackets. So how the queries are generated are specifically for each database. It's not a generic queries. The query generated specifically by the entity framework provider. So we know that are truly compatible with the databases. Why? Because we are basically relying on their engine to generate the valid queries. Also, one thing that I would like to highlight is that if you see the source and check all the projects, which you will see there the examples and so on and so forth. I don't know why the page is not loading completely, but the thing that I want to highlight is that this framework doesn't use any external references. Everything that is generated is pure entity framework valid code. So we use their infrastructure with a small modification.
I had it live on my side, Jorge. If you want, I can share quickly.
I will stop sharing. So yeah. So the idea, if you go to the source folder, you will see like a lot of projects. And then if you check all of them in general, there are no external references. All of them are only entity framework infrastructure. So the framework is super light, really small in size, and doesn't interrupt your normal flow. And also doesn't depend on anything else. All the code is generated by us, and everything else is entity framework, pure entity framework. So the thing is that it's not this crazy framework that includes a lot of other references and things like they might break. It's pure entity framework code. Basically, we did modify providers and a way to extend them. So that's kind of the beauty of it, that is kind of light. Well, it's not kind of light, it's really light, really fast, and totally compatible with the entity framework provider. So that's kind of the beauty of it, at least for me, that you don't require any crazy dependencies or things like that to make this work. So let me share the screen again. I think you need to stop for a while.
Yeah.
So let's go back to the demo. So here, if you want to see what is happening, you can download the databases, and you will have a zip with the database for the data itself, this one, and for the deltas. So each is stored in a different place. In a real scenario, you can say the deltas in a different database. For example, the data can be in Microsoft SQL Server, and the deltas, you can save them in Postgres if you want. So there is no requirement that it has to be the same. So now that we have one client and we did some changes, so we have deltas, right? So let's add another client. So if I want to make these two the same, client number one needs to push the deltas to the server. So see, deltas for push. If we see the server, there is like one delta here that came from client node one. So in client two, I can just pull the deltas. And I will be able to have all the records from database A. So for example, here you see that the last one is Jolie Bergstrom, and we have Jolie Bergstrom here. So let's add one record here. This will be you, Javier. When we save this, it will generate delta, which is a new transaction that we're saving in the database. If we download this to view it, you will see that there are two parameters. Parameter one is for the name column, and the second one is for the last name column. And here you have the query. So see, it's kind of really simple to understand. We're just recording the transactions, then sending them to a centralized place, download it in another client, and then you process the right query for you. And the framework is in charge of all of that. It's like kind of one or two lines that you need to implement. It's not so much code that you need to do. So let's push these deltas. Now, when I push them, if I pull them in the client one node, I will have all the records from the client node two and the things that I just added, which is you in this case. So if I pull this, then here is your record, Javier. And you will have no phone numbers because I didn't add anything. And I can add a phone number for you. So let's add a random number. Let's save it. Now we have another delta. If we check it, you will see that there is the phone number here. So when I push this to the server will have more deltas, and then we can pull them in the other client. And now here, if I select you, now you have the phone number. So it's kind of really easy to see how the implementation works in here. You can add as many clients as you want. And in the end, you can download the databases for your client specifically, or for all the clients. In general, if you click here, you will see the database for all the nodes. You will see the deltas database and the data exactly. And if you don't want to generate for other databases, you can just uncheck this. And the deltas generated will be smaller because it will only generate deltas for the same database engine that you're using, which means if you are in SQLite, it will generate deltas that are only valid for SQLite. In a lot of cases, you don't need to generate deltas for a different database engine. Within an organization, you might have everything in SQL Server between branches of a company. But when this gets really interesting is for MAUI development and for Xamarin. Well, not for Xamarin because it's Net 6, so it's not compatible with Xamarin. But what I'm trying to say is that it's interesting for the mobile point of view. You can create your main database in Postgres, MySQL, SQL Server, and then have the devices saving the data in SQLite. Even you can do it with WebAssembly clients. As you can see in this example, everything is run in memory. This doesn't require a server. There's no server side in here. So there are a lot of possibilities for using something like this. It's up to you how crazy you can get. The framework is able to handle what the framework is supposed to handle, which is delta recording, and then put together delta processing, which is putting together the deltas. Then how often you synchronize, how you decide how to move the information between the things is mostly up to your own organization. So that's basically it for the demonstration. It was kind of a lot of fun to put it together. And it's a really easy way to tell the people, okay, this is how you can test it without having to write a line of code. So that's everything from my side, Javier. Anything that you want to add?
Just that the idea here is you can test it, but you can also see the statements. You can also see the deltas. You can also download the database, so you can have a really clear picture of everything that is going on. And of course, you can go to the repository and take a look there. There is a couple articles about data synchronization that you can check on Hodge's blog, and there is going to be more and more documentation coming soon. And I think that, of course, I will not leave XPO hanging, so we should replicate this as well with our XPO SynFramework. And I believe, like Hodge, we should host this in any of our servers or any place that they can start playing with it.
It's ready to host. I was just needed to record this video because in this little text here, I put that, okay, this is a video on how the
everything is gonna work.
The playground works. So I was just waiting for the video to publish it. I have the server ready and everything. So Perfect. Soon I will post the link everywhere so people can start playing around with it.
All right, guys, as always, give us feedback and start using it. And if you find anything, just put an issue on the repo and we'll go from there. Thank you, everyone.
Bye. Take care.
Take care.